This is a real example about an IPRAN network. It has two different core sites, core site number 1 and core site number 2. The real IPRAN network doesn't depend on only one core site. It depends and it consists of a multiple of core sites. This is to enhance the redundancy and enhance the network capacity, and the core sites are geographically deployed all over the country of the IPRAN operator, and the IPRAN sites, the mobile service access nodes, are geographically deployed all over the country of the IPRAN operator, and the IPRAN sites located in the access connects the mobile users with its different services 4G, 3G, 2G and 5G. The IPRAN sites are distributed to the different core sites. We can find a number of IPRAN sites supported by the RNC, BSC, MME and SGW in core site number 1, and we can find another number of IPRAN sites in the access supported by the RNC, BSC, MME and SGW located in core site number 2. And the IPRAN network must have a different core sites to be able to support the disaster recovery in case it has a total failure in one of the core sites. Another core sites can carry the services that is affected by the failure of the first core site. We can also see that we have a multiple of nodes. We can have 2 RSG nodes per core site. This is for more redundancy, and we can also find that in the aggregation layer of each core we have 2 ASG nodes, and in each core site we have 2 root reflectors. For the first core site we have RR1 and RR2. RR1 and RR2 will be responsible to establish the required BGP peering with the RSG nodes and the ASG nodes. We can find also that each pair of aggregation nodes is connected to the core sites. For example, we can see that ASG1 and ASG2 is connected to core 1, core site number 1 and core site number 2. This is to enhance the protection. If a total failure occurred in one of the core sites, the aggregation node can get another core site, and each pair of aggregation nodes connect its access ring. This is an access ring and this is another access ring. In each access ring we will have a number of cell site gateways: CSG1, CSG2, CSG3, this is for the first ring, and CSG4, CSG5, this is for the second access ring. And in the IPRAN network we will have a huge number of access rings connected to a pair of ASG nodes, and the ASG nodes should be connected to at least 2 core sites in order to protect itself from any total failure that may occur in one of the core sites. We can see that in the access ring each cell site gateway is physically protected. For example, CSG1 node can connect to the aggregation layer by the direct connection to ASG1, and it can have another protected link to ASG1 passing through CSG2, CSG3, ASG2, and finally ASG1. Any cell site gateway will have a dual connection to the aggregation layer. This is also for more redundancy and more protection, and each cell site gateway connect its access service nodes, PTS node B or E node B, or even in 5G G node B.